the inspiration about this fertilizer and what are you trying to bring up?
Yes, so we know that for thousands of years, urine has been utilized as a fertilizer to sustainably grow food, especially in Asia. You go to China, you go to India, people have been using urine in crop growing. But we know that the nutrient content in urine, when it is liquid, is really diluted so much with too much water, because we know that over 95% of urine is actually water. So that makes it difficult if we're going to use urine on a large scale. So our motivation is to concentrate the nutrient content in the urine into a small solid material, so that we don't have to transport too much of it if we're going to apply in agricultural areas. And then we get it concentrated in a small solid, so that we can make it possible to easily store it, to easily transport it, and also to easily apply it in different agricultural fields. I am happy to be here today to check on the experiments, which are going on very well. Clearly you can see the difference in performance of the fertilizer, the dried urine fertilizer, in the different soils. And I'm really so excited about the competence of the NARO scientists we are working with, because clearly we can see the difference, and it will be able to guide farmers on which soils this dried urine fertilizer can be applied.
Wonderful, wonderful.
So my name is Onesimus Semalulu. I'm a research officer with the NARO, Kawanda. Here we are doing an experiment to evaluate different types of fertilizers, and in this case we have the dehydrated urine, we have the liquid urine, and we also have DAP, diammonium phosphate. Each of these materials is being tried out on 3 different soils, which were collected from 3 different geographical areas. And the fertilizers are being applied at different rates. We have half of the recommended rate for maize. We have full rate. We have 1.5 rate, 1.5 of the rate. Also have twice of the rate. Our test crop is maize, and we are growing this crop for 6 weeks because being a greenhouse study, we cannot afford to have the maize to grow to full maturity in a greenhouse. So at 6 weeks we shall harvest the maize and see how much biomass will have been generated at the different rates of fertilizer and soils that were used in the study. The idea is really to assess whether especially we are particularly interested in the dry dehydrated urine, to see its fertilizer value, whether if a farmer used it, he can benefit, how much he can potentially benefit, whether it is compared to the other materials. The commonly used fertilizer is the DAP, diammonium phosphate, but now these are new fertilizer materials coming up. So we are evaluating it against, we are evaluating the dehydrated urine against the known diammonium phosphate to see how it compares with what we exist. That's what we have.
Okay, thank you. Thank you. How is it faring so far?
So far, the experiment is going on well. We are seeing clearly a difference in soils. Different soils respond differently, but we're also seeing a difference in fertilizer rates. But then maybe the differences in fertilizer rates will become more eminent as the study goes. But we are beginning to show differences in the fertilizer rates. And so far we are seeing, yes, the dehydrated urine is a good product, but how good, we are yet to assess.
Wow.
But it's a promising one.
Oh, wonderful, wonderful. Delighted for your experiment. I understand now about the fertilizer. As I'm here, you have really put me to books. You have lectured me really. Okay. I feel like I'm now a scientist.
So you want to say that just get the fertilizer and apply it to any soil.
Okay.
So the evaluation of the soil is
the variation is also,
and this is clearly evident from here. You can see here.
The soil is different.
that the crops are really totally different from this side.
Due to the
This soil, the soil on which they were applied here, is different from the soil here.
Because the only variable we have here is the type of fertilizer applied and the quantity. Yeah. Then these are different soils. These are different soils. And you can see the soils are behaving differently.
it must be either kire or something.
And now then the real thing also will be in the field. The soil is restricted here in this bucket. But in the field, the soil is
the roots can
go far, and the soil can't be the same in one, just where the roots are.
Okay.
So then, while the soils here are different, the climate factors are the same.
Okay.
But in the field, one village can have rain, but the other may not have.
Yes.
So that variation can also have a difference cause a difference in the response
growth and
so we want to subject this to also those other parameters.
Okay.
Well, our scientists taking measurements also say something.
Let me get something.
We can also talk about this experiment.
I thank you for the good work. What would you say about the fertilizer that we are looking at?
Fertilizer dry urine is proving to be good.
Okay.
It's doing good, compared to the liquid urine actually.
Okay. So the solid one is better?
Yeah.
Okay. Thank you. Sorry for interruptions.
So